Welcome to today's lesson. Today's lesson is on differentiation of polynomials. Now, what is differentiation? Well, differentiation is the process of determining the rate of change in a quantity with respect to another quantity. Well, my work here is to teach you the trick on how to differentiate a function. But there's a guiding formula. And what is the guiding formula? I'm going to give you very soon. Now let's assume y is equal to x raised to power n. And the question say I should differentiate this function. You see, what I'm going to do is to differentiate y with respect to x. So y is said to be the dependent variable and x is said to be the independent variable. So what do I do when I'm asked to differentiate? It simply means a reduction of powers. Very simple term for us to understand this. So the guiding formula is this. The y, the x will be equal to, now I'm going to take the power to the side, which is n, and reduce the power by 1. That is simply how to differentiate. That's just the formula. You bring the power to become the coefficient and then reduce the power by 1. Now let's get down into some examples. Now, example 1. If y is equal to x cubed plus 4x squared minus 2x plus 5, find the y, the x. That's the question. So what do I do? Very easy. The y, the x will be equals to, bring that to the power 3, x, then reduce the power by 1, plus, bring that to the power 2. There's 4 here as a coefficient already, so you're going to multiply it by 4. And then x, 2, reduce the power by 1, minus, here the power is 1, so it doesn't really matter. So what I do is to write 2x 1 minus 1 plus, this is a constant, and so if you differentiate a constant, it's going to be 0. So the final working for this equation becomes 3x, 3 minus 1 is 2, plus 2 times 4 is 8, x, 2 minus 1 is 1, so there's no point writing it, minus 2, 1 minus 1 is 0, so it becomes x raised to power 0. And of course, you know that anything raised to power 0 is equal to 1. So that is the answer to the question. Very easy. Let's try at number 2. Now, number 2, I have y is equal to 2x raised to power 4 plus 5x raised to power 3 minus x raised to power 2 minus 7x plus 9. So let's just add that, plus 9. Now find the y, the x. The y, the x will be equal to, bring the power to the side. So the power is 4. So 4 times 2 is 8. X, 4 minus 1, 3. Plus, bring down the power, 3 times 5, 15. Reduce the power by 1, 3 minus 1, 2. Minus Bring down the power, 2. Reduce it by 1, so it becomes 1. 2 minus 1 is 1, but there's no point writing the 1. Minus, differentiate 7x, it is 7. Differentiate the constant is 0. So this is the answer to your question. So I don't want to follow the rigorous process I followed here by subtracting. No, this is easier than working it out this way. Let's go to number 3. Now, in number 3 question, I have y equal to, this is 6x raised to power 3 minus 2x raised to power 2 plus 5x minus 6. I'm looking for the y dx. So what is the y dx? The power is 3, so 3 times 6, 18. Reduce the power by 1, it becomes 2. Minus, the power here is 2, so 2 times 2, 4. X, reduce the power by 1, so it becomes 1. There's no point writing a 1. Plus, if you differentiate 5x, it's going to be 5. And if you differentiate a constant, it's 0. So that is the solution to the question. Like I said, it's easy peasy, right? Now let's go to number 4. Number 4 question is y is equal to x raised to power 3 plus 2x squared minus 10x. That's the question. So find the y dx. Very easy. Bring down the power, 3, x, reduce the power by 1, plus, the power here is 2, so 2 times 2, 4, x, reduce the power by 1, it becomes 1, there's no point writing the 1, minus, if you differentiate 10x, remember, it's going to be 10. And that is the fine answer to the differentiation to the question number 4. The first set of differentiation we've just done is called the first derivatives. Now, it is possible for you to also get the second derivative. Now, if the question asks you to look for the second derivative, what are they actually asking you to look for? Now, I'm going to use an example for us to get this. Now, let's take this as number 1 on the second derivative, number 1 example. I have y equals to 4x cubed. This is cube minus 5x squared plus 2x plus 8. Now, if the question asks you to look for the second derivative, it's asking you to find the square y, the x squared. This is how you represent second derivative. Now, the first one we did was just the y dx. But for second derivative, you're looking for the square y, the x squared. So what do? Very easy. You have to start from the y dx before you can get the square y, the x squared. So let's differentiate the function. We'll have 4x cubed minus 5x squared plus 2x plus 8. If I differentiate, this will be 3 times 4, that's 12, x raised to power 2 minus 2 times 5, 10, x plus, if you differentiate 2x is 2, differentiate constant is 0. So this is the first derivative. Now, second derivative will be the square y, the x squared. And so this will be from the first derivative, you get a second derivative. So you look at this time. 2 times 12 is 24x minus, if you differentiate 10x, it's 10. That's the answer to the question. It's very easy to get second derivative there is no difference from what we've been doing before now. So it also applies to if I have another example. Let's say y is equal to 6x raised to power 4 plus 4x raised to power 3 minus 2x raised to power 2 plus 3x minus 5. And the question say find the second derivative. So first of all, I had to look for the y dx. 4 times 6 is 24x raised to power 3 plus the power here is 3. 3 times 4, 12x raised to power 2 minus 2 times 2, 4x plus differentiate 3x, 3. Then you go again for the second derivative, the square y, the x square. 3 times 24. 3 times 4 is 12. You rename 3 times 2, 6 plus 1, 72, x raised to power 2. Plus 2 times 12, 24x minus, if you differentiate 4x, it's 4. That is the answer to your question. So we can see that this is very easy. It's not difficult getting second derivative. Now there's something I need to show you here. That another way you can represent a function is this. You know, I could have, for example, y is equal to 4x cubed. That's a very first example, minus 5x squared plus 2x plus 8. Do you know that I can represent this? Like if I differentiate this, for example, I will have the y dx is equal to 12x squared minus 10x plus 2. Do you know this can be represented as d in place of this y? In place of this y, I'll put a function. Open a bracket for 4x cubed minus 5x squared plus 2x plus 8, close the bracket, over the x. And it's equal to 12x squared minus 10x plus 2. This is 2. So here, this representation is the same as this. So instead of just giving me the function y is equals to this and then differentiate to get this as the result, I could just say d, the function I'm differentiating, the x is equals to the value I have here is what I also have here. So if you see this in any textbook, it is the same as what I have with this first and second equation. There is no difference, so don't get confused about this. Okay, I'm just going to give you one work to do under 8. Let's assume you have y is equal to, let this be 3x raised to power 4 minus 6x raised to power 3 plus 7x raised to power 2 minus, and let this be 5x plus 3. Now, I want you to differentiate this for me and tell me what would be the y, the x. Here, you're just finding the first derivative, the y, the x. Now, put your solution in the comment section.